All right, let's look at problem number 8. Okay, what is the chemical formula of the compound that is 11.19% hydrogen, okay, and 88.81% oxygen? All right, so this one right here is giving us the percent composition of something. Okay, so this one is giving us the percent composition of something, and from that something, we want to get the chemical formula. All right, there are actually a few steps to do this. Right, so let's go through this step by step. So step one, right? Step one is you want to turn to grams, and this is super simple. Okay, you just drop the percent sign and turn it into grams. So this one right here, 11.19% of H simply becomes 11.19 grams of H. Right. How about for O? It's the same thing. So 88.81% O becomes what? 88.81, okay, grams of O. Right? So again, first step, turn it to grams, just drop the percent sign and then turn it to grams. All right, step two. Let's go step two now. Okay, step two. Okay, your answers in step one, you want to turn into moles. All right, so let's do this. So how do you turn this into moles again? Remember the boxes and the squares. Remember this? Okay, so let's start with oxygen. I mean, with hydrogen. I got 11.19 grams of H. All right. So how do you turn this into moles? You need the molar mass, which is 1 mole. Remember, the molar mass of H is 1 mole of H is its atomic mass. So go grab a periodic table and you're going to see that 1 mole H is equals to 1.01 grams of H, right? Okay, now just to make it a lot easier for us, I'm going to round it off, all right? I'm just going to round it off to just 1. Just to make my life easier, I'm just going to round it off to 1, okay? All right, so the grams H will cancel out, and then you just do the math. 11.19 times 1 divided by 1, the answer here is 11.19 moles of H. All right, and you do exactly the same thing for oxygen. I'm going to do oxygen in red so you can see it. So I'm going to put it right here at the bottom. All right. Again, guys, there's nothing that goes at the first bottom box, right? Nothing here. Don't put anything here. It's a sin. All right. So again, it's 88.81 grams of oxygen. 1 mole of O is 16.0 grams of O. Okay, multiply 88.81 grams times 1 divided by 16. And what do I get? I get 5.55 moles of O. See it? All right. So we did step 1, step 2. All right. Now we're ready to do step 3. All right. Step 3. Divide by smallest answer. So you divide it by the smallest. Okay, so let's write it down. So our answer for H, what was the answer for H again? Was 11.19, right? And our answer for O was 5.55, right? We need to divide these two numbers by the smallest answer that we got. So which one is the smaller one? Obviously, it's 5.55. Okay. Right. So H divided by So H is 11.19 divided by 5.55 gives me 2.01. So simply let's just go 2, round it off to 2. And O, 5.55 divided by 5.55 obviously is simply 1. Okay. All right. Guys, step 4 is make it whole. But these are already whole numbers. So again, let's write that down. So step 4, whoop, step 4, okay, is you want to make them whole. Make whole. But these are already whole numbers. So the answer is, so you see those answers, they become your subscripts. So the answer here is H2O1, but again, 1 is always invisible in chemistry, so the answer is H2O. So that is the chemical formula for this problem right here. All right, so don't forget, step 1, turn it into grams. Step 2, turn it into moles. Step 3, divide it by the smallest answer. And step 4, make it into whole. All right, and that's how you do this thing. Okay, all right, let's look at problem number 9. All right, problem number 9. The chemical formula for H2O for water is H2O. All right, what is the percent mass of oxygen in water? All right, okay, hey. So guys, percent composition. To get percent composition, okay, to get the percent element of anything, the first thing you need to do, step 1, is get the molar mass. Step 1, okay, find molar mass. Okay, molar mass. All right, and you should know how to do this. That's step 1. So H2O. So what are the elements in H2O? I got H and I got O. How many H's do you have? 2. And how many O's do you have in H2O? 1. Get a periodic table, find the atomic mass. H is simply 1.01. So I'm going to make my life easier. It's just going to be 1 for me today. So 2.0. How about oxygen? It's 15.99. So I'm going to make my life easier. Again, it's just 16 for me now. 16. And what do? You add those two up and you get 18. All right. It's that simple. So step 2. Right. So step 2. How do you do step 2 now? Step 2, you just divide the subtotal for each element divided by the overall mass, which is the molar mass, times 100. So let's do H. So that's going to be percent H. Right. Percent H. So look, what is the subtotal for H? It's the 2. Okay. 2. So I'm going to divide 2 divided by, what's the molar mass? 18. So that's divided by 18 times 100. And you get what? So 2 divided by 18 times 100 is simply 11.11%. And that's your H. Okay. And you do exactly the same thing for O. Percent O is equals to, again, what's the subtotal for O? 16. All right. So 16 divided by, what's the overall total? 18 times 100. Okay. And this is now what? 88.89%. All right. Okay. Actually, you can check if this is correct. Why? If you add these two up, okay, if you add these two up, it should equals to close to 100%. Okay. See that? And that's how you double check this. All right. But look at the question. The question is, what is the percent of mass of oxygen? Oxygen. So we only need oxygen. So the answer here, okay, the actual answer here is only what? 88.89% oxygen. All right. Because we're only looking for oxygen. So that's the only answer right there. See it? All right. Cool. All right, let's look at number 10. All right. All right. What is the percentage of H present in water? What is the percentage of H present in water? Well, this problem is almost exactly like the last problem we did. This one right here. See it? So here, the percent that we need now is the H right here. All right? And that's what we need. So if you look closely at this one, you do exactly the same way of doing this. Get the percent composition for water. Again, find the molar mass and do it one element at a time. For this one, the answer we need is H. So therefore, the answer here again is 11.11%. Okay. So this one is almost the same problem as number 9. But this time the answer that we need is H right here. Okay. That's the one that you want. Cool. All right. Let's look at number 11. What is the molecular formula of a compound whose molar mass is 34 grams and whose empirical formula is HO? All right. First of all, guys, let's look back. What the heck is empirical formula? Guys, the empirical formula is the simplest formula. So empirical, okay, is the simplest formula. Simplest formula. Okay. This means that all the subscripts, you cannot find a number to divide all the subscripts with and get a lower answer. For example, let's say, uh, and this is just some random stuff I'm writing down, all right? NO3. See it? Okay. So what are the subscripts here? 1 and 3. You can't find a number, all right, to divide 1 and 3 with and get something lower. So that is already the empirical formula. On the other hand, the molecular formula, guys, the molecular formula is the multiple, okay, of empirical formulas. Okay, right. Or you can still simplify this. So you can further simplify a molecular formula. So for example, let's say you got N2O6. Okay, if you look closely, you see the 2 and the 6. Okay, the 2 and the 6. Can you think of a number to divide 2 and 6 and get a lower number? Yes, you can divide both of them by 2. Okay, and therefore you can get in 2 divided by 2 is 1, 6 divided by 2 is 3. See that? So this is the empirical formula. Okay, so this makes it so NO3 is the empirical formula of N2O6. See that? So that's the difference between the two. All right, so let's figure out this problem right here. It says there, what is a molecular formula? So we're looking for molecular formula, which means the subscripts, you can get a number, divide those subscripts, and get something lower. Okay, whose molar mass is 34 and whose empirical formula is HO. HO. All right, so how do we do this? First, let's find the molar mass of HO. Just to compare, find the molar mass of HO. So H and O. You got 1H, 1O. Multiply this by the mass, which is 1.0. You get 1.0. O is 16. This gives you 16. Then remember, you add them both up, you get 17. So the molar mass of HO is 17. All right. So, but look, the molar mass of the given is 34. So remember, the empirical formula is simply a multiple of, the molecular formula is simply a multiple of the empirical formula. So let's grab that 34 and divide it with the molar mass that we got, equals to 2. Right? All right. What does that mean? This means that this 2, all right, this means that the 2 guys, Okay, it's just a multiple, all right, of the formula. The formula is HO, right? So HO, that's a 1 and O1, right? So you use that 2 to multiply the subscripts. And what do you get? H2O2. And that is your molecular formula right there. So that's how you do it. So again, just grab the molar mass of the given empirical formula, get the molar mass of the molecular formula, divide it, find that number, and use that number to multiply the subscripts of your empirical formula. And that's how you get that answer right there. All right, good. Let's look at number 12.